This is our next invited talk. We're going to conclude our Flower Monthly for October by diving into blockchain and seeing how that type of exciting technology can influence how we build federated learning applications. And to do that, we have a world-class expert in this space. His name is Kwangkee Lee. He is a principal investigator at an exciting organization called InnopiaTech. And I'm really delighted to have him here today and sort of pass along over to him to tell us all about it.
Okay, my name is Kwangkee Lee. I'm working for InnopiaTech in Korea. It's a company. Okay. So let's get started with the question of why BCFL is required. BCFL means blockchain-enabled federated learning. Some critics argue that blockchain and Web 3.0 are overly complex architecture for problems that do not exist. But the technologies and market landscape are rapidly evolving, and we are trying to find an answer. As we know, while FL technology has made significant advances, it still faces challenges such as single point of failure, malicious clients and false data, and the lack of incentives. Recently, blockchain has been widely identified as a potential solution to address the above-mentioned issues. The vanilla federated learning is based on a traditional client-server architecture in which trustworthy central authority is needed for coordination. On the other hand, the real-world use cases of FL require untrusted settings that do not rely on a single central server and have to deal with dishonest clients effectively as well. So BCFL has an idea that blockchain is used as the underlying architecture for federated learning has gained traction lately and has become a rapidly evolving area of research and development. But for blockchain, there's a core problem that needs to be solved. The problem is well known as the blockchain trilemma. The blockchain trilemma states that it is impossible for a single blockchain network to satisfy all three characteristics at the same time. That means we can only meet two of the three possibilities. In fact, in integrating FL and blockchain, we have the same challenges in managing the trade-offs among the three desirable attributes. So a sort of compromise is needed in real-time deployment. And today, I'd like to introduce our ideas and efforts to solve the trilemma in BCFL applications. It is worth mentioning that there are several design choices for integrating federated learning and blockchain features, each with its own pros and cons. One possible option is tightly coupled, in that the clients of FL are also nodes of blockchain. In other words, the clients that not only train the local models, but also verify the updates and generate new blocks. Another option is decoupled. In the case no node works in both systems. In the case the system consists of a blockchain subsystem and a federated learning subsystem. Considering that blockchain is still evolving, and so is federated learning, one of the most important questions to BCFL design would be if and how tightly FL and BC should be integrated. We believe that decoupled or at least loosely coupled integration is inevitable for real-world deployment. And considering FL still faces various technical challenges and in its early stage of industry adoption, flexibility and extensibility are important. In addition, we realize that great efforts are being made in the Flower community to make the FL real. So we intend to integrate tightly with Flower to observe and reflect the advances of FL in a timely manner. Based on the design choices mentioned before, we proposed the novel reference architecture for BCFL and implemented and verified it in an Ethereum development environment. One big difference of BCFL is that in traditional federated learning, the selection of local clients and aggregation of learning outcomes are performed under the control of the central server. But in BCFL, all of these processes are monitored and managed through the smart contract. Core ingredient of BCFL includes smart contract, IPFS, DID, and incentive reward mechanism, etc. They are all rooted in blockchain, Ethereum, and Web 3.0, but are defined and be used for BCFL. Next, let me explain how we integrate blockchain with Flower, which I believe we are the first. The principle of our implementation is to make BCFL compatible and interoperable with existing and evolving Flower framework. So no change in Flower framework structure and code is allowed. Thanks to the flexible Flower architecture, all we need to do is simple addition and extension to integrate BC with FL. As addressed in the Flower materials, even though the current implementation uses gRPC, we can add alternatives for communication and information delivery. In short, our proposal is to use IPFS, interplanetary file system, without any change in Flower framework. The difference is in our proposal, CID, content identifiers of the stored models in IPFS are delivered under the control of smart contract. That means in Flower, models are directly passed through the gRPC channel. On the other hand, in BCFL, model delivery happens via IPFS under the control of smart contract. No direct delivery of models between the server and client is happened. As you know, in Flower framework, client is the abstract base class for Flower clients. This means that abstraction of client defines a few abstract methods, such as get parameter, fit, and evaluate, that need to be implemented in the Flower client class. To reuse all the great features of Flower and make BCFL interoperable with Flower, we defined the abstract base class for BCFL clients called ETH client, which has the same set of abstract methods of client. In addition, we have added a few more abstract methods that need to be implemented in BCFL client. For server side, we defined ETH server, which is inherited from Flower server. As a result, we can start the BCFL server as the same way Flower server is started. Furthermore, all the strategies of Flower is used without any changes of Flower framework code. Actually, we submitted a full request a while ago, but we have ideas for further improvement. So I'd like to discuss these points with the Flower community later. For now, we focused more on the verification of architecture rather than the FL performance analysis. However, due to our implementation strategy, we expect exactly the same performance and behavior as that of the Flower framework. Future directions. We will focus more on performance evaluations. And mainnet deployment is another important milestone for us. And sure, actively following up on the progress of the flower framework would be important for us. Especially fair and efficient contribution evaluation of the participating clients is critical to BCFL, but we know it is very challenging. As you know, there are several outstanding works for contribution evaluation out there, but we need more thorough and intensive comparison and evaluation from the perspective of complexity and performance. We have a long list of recently published works for BCFL, but again, I believe we are the first and only so far to integrate with flower. For the plausible target application of BCFL, we are working on a platform for digital healthcare, especially for DCT, decentralized clinical trials. In our scenario, participants of clinical trials are rewarded as per their contribution to federated learning training. We also expect FLTM including BCFL to be useful for a more wide area of applications. Let me see some simple demonstration. The first thing is to publish the task with some characteristics of the models. And after that, the trainers will participate. First client is participating with the registration of their data. And second participant. As you see, we use all the framework, flower framework. You can see the familiar flower framework log here. As the participants, all the clients are participating, the process is beginning. The FL training is in progress. I'd like to point out that the all the transaction is stored in the blockchain network, so we can scan and check that transaction. That's the beauty of this one. That's the beauty of the blockchain characteristics. And this is the demonstration. The final model is NFTized, and then can be transferred to the marketplace, and the buyer and the seller can exchange their information to this demo. So we just completed some basic building blocks of the FLTM and the BCFL. Okay, that's it.
Perfect. I haven't seen a demonstration like this before, so it's really pretty interesting. I can take a few questions because you kind of stuck to the time budget quite well. Let me take a couple of them from the Slack in different places. Yes, I have one question where they're interested to know, what do you think the most what are they saying? I guess they want to know what's the key application you see being enabled by this sort of framework? What's the one that you're most excited by?
I suggested the kind of model marketplace is a kind of pro application with this BCFL. So so to build a model, we need good data, and to give a reward and incentive is important thing for the participants to contribute with their data. In our case, we are more, our first target is kind of a digital healthcare scenario, but I think it is more widely, we have more wide application areas.
Oh, for sure. Yeah, I could see that there's a kind of wide diversity of applications one could build. I guess they were just curious about what you think is going to be the first mover, but I see the model marketplace, data marketplace makes a lot of sense. I'll take another look to see what we have here. If anyone else, I don't know, maybe if Julian or Javier have a question. Otherwise, I'll go to the pool. There's a question about I guess the different types of cryptocurrencies and so on, and there was some discussion about the speed of transaction and if that would be an issue for building one of these type of architectures. There's some discussion about Bitcoin and Ethereum. But do you think this is an issue, or would you, I don't know, I'm not familiar with the area, but would you build another token to build these systems, or would you build it on top of these existing blockchain cryptocurrencies, or perhaps is the question a bit misguided in nature?
Each have different idea and strategies, but my first target is to deploy our technology to the existing blockchain networks, such as Ethereum and Ethereum compliant mainnet, such as we have Polygon and other mainnets that support scalability.
I see.
Having our own, building our own blockchain network is another option, but it could be very difficult, and it could be a very huge work.
For sure, yes, I see. But I guess that there are also this issue of performance that comes up sometimes. If for the type of networks you're building on top of, is performance and the amount of transactions that can, or I guess in this case not transactions, but the amount of verifications and so on, that's not an issue, or
yeah, that's a as I mentioned, we have blockchain trilemma. The scalability is the real issue for any real world deployment. Especially blockchain is designed for simple transaction, but the artificial intelligence and BCF federated learning, if we have to record all the those kind of transaction, it would be a kind of huge, and network cannot endure that amount of traffics, and speed is not so we made some kind of compromise. So there are there are tens of hundreds of different BCFL architecture. They have their own idea to compromise the security, decentralization, and scalability. So I'd like to stress that our approach is unique because we rely on the Flower framework. Most of the core functions of federated learning is happening in the Flower framework side. So I'd like to suggest we more kind of discussion and the would be helpful.
Well, yeah, I mean, along those lines, what would be a modification to the existing framework that would make your life easier, or maybe would enable you to build something even more powerful? What would be the number one on your wish list that either us or people in the community might build to kind of supplement what you're trying to drive towards?
We first believe that some kind of modification is necessary to support the model exchange through IPFS. But as I showed in my presentation, no kind of change is necessary. Just extension and the addition of the is enough to implement the BCFL, our architecture of BCFL. But as we go on, we may need. We can find some different idea.
I see. Understand. Well, I think those were the main questions I saw being asked. The most substantial ones.
I have one small question. Can I ask?
Oh yes, please go for it. Yes.
I think it was very interesting talk. I have just one probably very simple question. Does your solution or current solution rely on some particular hardware, or is entirely a software solution and anyone that has, the whatever is needed to sign in the blockchain can participate?
No hardware dependency at all, I think.
Okay, that's cool. I was checking Innopia website and I saw some hardware components, so I thought maybe there is some hardware involved. But okay. Well, thanks.